Hello students, today I am going to teach you radius of curvature and derivations related to this. So brief idea about radius of curvature I am going to go with. If you take any P be a point on the curve C, tangent is drawn at point P. Okay, so circle having the same curvature as the curvature at P touches the curve P is called radius of curvature. The center of radius of curvature is called center of curvature. So you can see, very simple, you can understand how the construction of radius of curvature is done. Okay, so we just go through radius of circle curvature is called radius of curvature, which is denoted by rho. So this construction is done here, students, you can see here. So now what I say, so I take, yes, here is the point P. I'm going to take the point P, and here I'm going to take O. Origin it will be O. Then I say that P is a point on the curve C. So let this curve be denoted by C. This is what you can orally understand and easily remember. That is very important. And I say that circle having same curvature as the curve at P touches the curve P. So this point P, this curve is touching where the curvature of this circle is there. So you can just see here, friends, the center of the circle of the curvature is called center of curvature. Radius of this circle curvature is called radius of curvature, which is denoted by rho. So this you have to remember. So you can see this is x, y, origin, this is 0. So this is a brief idea. In 2 minutes I have given radius of curvature. Now we go to the some of the very important note which I am going to use in the derivation. So please remember this, friends. I can see if k, so if I take any k, right, if I take any k which is greater than 0, is curvature of curve at P, then the radius of curvature of curve of rho is 1 upon k. So this I am going to use in the derivation. Okay, please remember this. This follows from the definition of radius of curvature. Just now I have told you. And the radius, that the curvature of the circle is the reciprocal of its radius. So please remember this. So just note 2. If for an arc of curve, if I take this as psi decreases, as s increases, then d psi upon ds is negative. That is, k is negative. This is just a second note. Please remember this. But the radius of curvature is non-negative. So to take rho is equal to 1 upon k, which is equal to ds upon d psi. This is a very important note. I'm going to use this in the derivation. Keep in the mind. And this some authors regards k also as non-negative. Please remember this, friends. K is considered as non-negative. K is equal to d psi upon ds. So just note which is very important, very simple, which is useful for our derivation of radius of curvature in Cartesian form. Yes, friends, I am going to derive today radius of curvature in Cartesian form. So to derive this, every time please remember the keyword. You have to first construct, then substitute the equation, you will get the answer. Okay, I will start with let y is equal to f of x be a Cartesian equation of the curve C. So previously I have seen the figure. Please remember the figure in your mind. and A be a fixed point on it. Now let Px comma y be a given point on C such that arc AP is equal to yes. So just this is a denotation. So then we know that yes friends. Now we see I'm going to take just a brief idea about how we know that dy upon dx is equal to tan psi. So you have to remember this friends. Tan psi is nothing but dy by dx, which is the equation. Then please remember that where psi, yes friends, can anybody tell me what is psi is? Yes, in the diagram it is already there. Psi is the angle made by the tangent. Is it clear? So this is very simple. To the curve, I'm going to take the curve to the curve C at point P with x-axis, with x-axis. Am I right? So now you can see that what will be the equation now. Yes friends, very important, very simple. This is going to be ds upon dx. So this is the equation we are going to take. Ds upon dx is equal to 1 plus dy upon dx the whole square raised to 1 upon 2. This equation we have taken directly. Please remember this equation, and about this equation I have done the video. In the next class you can just go through that. So I will take this equation, right? Just differentiate this equation with respect to x. Okay, so just differentiate this equation 1. I say this equation 1 and I take this equation number 2. Differentiate equation 1 with respect to x. What we get here friends? Yes friends, you can easily tell me. Just I am going to differentiate this. So this is going to become d square y upon dx square is equal to sec square phi into d phi upon dx. Okay, so next is just simplification. How we will simplify? What is sec square phi? It is 1 plus tan square phi into, so d phi upon ds we don't have, so but ds upon dx we know. This is what we have, and d phi upon ds we know. So two equations I know, so I just modify this equation. D phi upon ds I say, and this is ds divided by dx. Okay, just for modification I have done here. Please understand this. ds I have multiplied and ds I have divided. Is it clear? Okay, so next just substitute the values now. So this is equal to 1 plus tan square phi into, yes, d phi upon ds. Do you remember that note I have told you to remember? In the note 2 you can go back the video once again and you can see d psi upon ds. I have given this as 1 upon rho. So I told you in the derivation I am going to use this, and now I am using it. So this is 1 divided by rho. And what about ds upon dx? Just now in the previous step I have done ds upon dx. So ds upon dx, I am going to substitute this is 1 plus dy upon dx the whole square raised to 1 upon 2. Just now I have written it. Okay, so just substitute the values. So what I get here, students, this is 1 plus dy upon dx the whole square raised to 1 upon 2. What I have done here, students, just I have substituted the values. Okay, and remaining is just simplification. So just simplify this. D square y upon dx square is equal to 1 upon rho. Just simplify this. I will take this 1 upon rho this side, and now 1 plus tan square psi. I'll just substitute this as ds upon dx. It is ds upon dx. I can see in this where I have written yes. Here we have in this equation we have taken this. Okay, so I'll just substitute the values. So come back to this. Okay, now I'm going to substitute 1 plus tan square psi as 1 plus dy by dx raised square raised to 1. Okay, just substitute this. So simplification will go like this. 1 plus tan square phi, I'm going to write this as dy upon dx the whole square. This is what I wanted to tell you. That is what we have already taken into 1 upon rho, and this is 1 plus dy upon dx the whole square raised to 1 upon 2. So this is power is 1 and this power is 1 upon 2. So power will get added. So 1 plus 1 upon 2 will become 3 upon 2. So please remember what I have substituted. Tan square phi as dy by dx. So just simplification. Therefore, easily you can see as students, d square y upon dx square is equal to 1 upon rho as it is. Here you can see as students 1 plus dy upon dx the whole square, and if you add this, it is power is going to add, and therefore this is 3 upon 2. Okay, just I will simplify that. Here I have just repeated this. I have written 1 upon rho outside, so only this is remaining. So now this is written as 1 plus dy upon dx the whole square raised to 3 upon 2. Just now I told you the powers are going to add. 1 upon rho I have taken outside. Okay, so now I want to know what is rho. So just take this rho on right hand side, d square y upon dx square on left hand side. So this equation is rewritten. Therefore rho is equal to, this is going to be 1 plus dy upon dx the whole square raised to 3 upon 2 divided by, so I have kept this equation as it is. Only this equation I am going to bring in the denominator, that is d square y upon dx square. Okay, so now I will just simplify this, students. Remaining I am going to just simplify this equation. So this is going to be, yes, for our simplification I will take y1 as dy by dx. Just put y1 as the first differential dy by dx, and y2 is going to become d square y upon dx square. So therefore, the same equation, above equation, is written as rho is equal to 1 plus y1 square raised to 3 upon 2 divided by y2. Yes, friends. This is the derivation. This is the derivation. So therefore, I say that this is the Cartesian form of the radius of curvature. So I have done it very quickly. Just if you have any doubts, you can go back to the video once again. Next, continuously we are going to go with the deriving radius of curvature in parametric form. Yes, students, I'm going to derive radius of curvature in parametric form. Quickly, you're going to take, let x is equal to f of t and y is equal to g of t with the parametric equation of the curve C, and p of x comma y be a given point on H. Then, yes. So when they have given this, just take, then remember this, students, I will use dy upon dx is equal to dy upon dt divided by dx upon dt. So multiply and divide by dx dt, dy upon dt divided by dx upon dt. So in this derivation, students, what you have to remember is I am going to differentiate this once again. Differentiate this with respect to x. So what you are going to get? You are going to get d square y upon dx square is equal to, just I am going to differentiate this with respect to t. So this is, now you can write dy upon dt divided by dx upon dt into dt upon dx. So I wanted this in the form of dx. So just I have differentiated this with respect to x. So this is dx must be there, but I have taken here dt. I have multiplied by dt and divided by dt. Dx I have just written here for my simplification. So now this equation is written as, friends, okay, so we'll just simplify this. This is equal to dx upon dt into d square y upon dt square minus dy upon dt into d square x upon dt square divided by, so just I have simplified this, u divided by v rule. So please apply u divided by v rule, students. You have come across differentiation with respect to t. If you take u divided by v is going to become u v du minus u dv divided by v square. So therefore I will keep v first as it is, dx upon dt I have kept it as it is. Then I have multiplied by differentiating u, that is d square y upon dt square, minus dy upon dt as it is into differentiate v, that is d square x upon dt square. Now this is divided by I'm going to take dx upon dt square. So in RHS it is same, d square y upon dx square equal to, okay, so this is for our simplification. I have written in this form. Okay, so write down the next step, students. Substituting the values of dy upon dx and d square y upon dx square. So you have come across how we are going to take the equation now. Yes, our equation is going to written as in the form of y1 and y2. So you have come across what is y1. Dy by dx is going to become y1 and d square y upon dx square is going to become y2. So you can just simplify this, friends. You will get radius of curvature y is equal to f of x. So now I will take d square y upon dx square, as this is rho is equal to 1 plus y1 square raised to 3 upon 2 divided by y2. We know that. So we know this equation, students. So I'll rewrite this equation y as dy by dx and simplify, modify this such a way that I get this values. Okay, so I will take like this, y1 plus 1 plus y1 square raised to 3 upon 2 divided by y2 we have taken. Okay, now just simplify this equation. Just see. So this I am going to write 1 plus dy upon dx square raised to 3 upon 2 divided by d square y upon dx square. Okay, so quickly we are going to simplify this equation. Now wherever differentiation we have taken, this is with respect to x is there, I am going to write this with respect to t, so that this equation must be comparable. Okay, so I will write like this, so please take this rho is equal to 1 plus dy upon dt dx upon dt square raised to 3 upon 2 divided by d square y upon dx square. Just substitute d square y upon dx square just now what we have calculated. So just substitute the values, dx upon dt into d square y upon dt square minus dy upon dt into d square x upon dt square divided by dx upon dt. So just substitute these values what we have just now calculated. Dx upon dt square into dt upon dx. If you want, you can simplify this. So this is going to become rho is equal to substitute all the values, friends, you will get it in this form. Rho is equal to 1 plus dy upon dt divided by dx upon dt. Just previous value I am going to simplify. The whole square raised to 3 upon 2 divided by dx upon dt into d square y upon dt square minus dy upon dt into d square x upon dt square divided by, this is going to become dx upon dt the whole cube. So previous step I have just simplified. Okay, so now this is our equation. This is the radius of curvature. I have used the formula. Now we will simplify. So before simplifying, I will just put or just say where x dash is equal to dx upon dt. Just for our simplification, I am going to take this x dash and y dash dy upon dt. X double dash is written as d square x upon dt square, and y double dash is equal to d square y upon dt square. So just substitute this value properly in the equation, you will definitely get this. Therefore rho is equal to x dash square, okay, this is square, plus y dash square raised to 3 upon 2 divided by x dash y double dash minus y dash x double dash. So this is the Cartesian form of the radius of curvature in parametric form. Okay, so we have done with this. So notes are also uploaded, please go through it once again. If you have any doubt, please ask me. Yes friends, next continuously we are going to take again derive radius of curvature in polar form. Quickly I am going to take radius of curvature r is equal to f of theta with the equation of the curve in the polar form, and the point I am going to place in that is p of r comma theta be a point on it. Then we know that what we know, students, we should know that polar form, polar equation we should know. So I am going to write equation for polar, that is 1 divided by p square is equal to 1 divided by r square plus 1 divided by r raised to 4 dr upon d theta the whole square. This is the equation of polar form. Now for this polar form we are going to find radius of curvature. Please remember this formula is polar form. We are going to find radius of curvature rho. Okay, please keep in your mind we are trying to find radius of curvature in parametric form, polar form, right? Different forms we are going to simplify. Okay, so now I'm going to differentiate this. So let's differentiate this. Differentiating with respect to r. Okay, so let us differentiate this with respect to r quickly, students. This is going to become minus 2 upon p cube dp upon dr is equal to minus 2 upon r cube plus dr upon d theta the whole square in the bracket minus 4 r raised to minus 5. So again this is u into v. So therefore this is going to become plus, continue this plus 1 upon r raised to 4 as it is, and this is into 2 into dr upon d theta into d upon dr upon d theta. Okay, so this is differentiation, students. Very simple. I have taken only one formula that is very important, d upon dx x raised to n. So this is n x raised to n minus 1. In the denominator if it is there, then I have taken this as negative in the power. Suppose this is 1 upon r square is there. If you take this in the numerator, r raised to minus 2 is there. So you can easily simplify this as minus 2 into r cube minus 2 minus 1. So it is minus 3 you will get. If you take in the denominator, it is going to become positive. Same way, remaining simplification is done. Okay, so now quickly we're going to simplify this, ones. Okay, so this is equal to minus 2 r cube minus 4. So just this is simplification. 4 divided by r raised to 5 dr upon d theta the whole square plus 2 divided by r raised to 4 d square r upon d theta square. So you can just see minus 2 upon p cube dp upon dr. Minus 2 will get cancelled. So only p cube I will take it down this side. Okay. Okay, students, you can just simplify this. Minus 2 from here, minus 2 from here, and minus 2 from here will be done. Simplification. Okay, so therefore you will get it in this form. 1 divided by r cube. So minus I have taken outside, so plus is there. 2 I have taken outside, so 2 divided by r raised to 5 dr upon d theta the whole square plus you will not get because minus I have taken outside, therefore this is going to become minus 2 is outside, so only 1 you will get here. 1 divided by r raised to 4 d square r upon d theta square. If you not understood, students, please see that you go back to the previous video and you can see. So now upon d theta the whole square minus 1 upon r raised to 4 d square r upon d theta square. Okay, so now just simplify. This equation is rewritten as, here I will write this head, therefore rho is equal to dr upon d theta the whole square minus r into d square r upon d theta square. So for our simplification, simplify in this form, and then I have taken here 1 divided by r raised to 5 I have taken outside. Is it clear? So this r raised to 5 I will take it outside. This is r is already there, so this is going to become r raised to 6 into 1 divided by p cube the whole divided by r square plus 2 dr upon d theta the whole square minus r into d square r upon d theta square. This is our, so radius of curvature is written as, substitute all the values. Go back, rewind the video once again, come across pedal equation p cube. Just I will substitute this value. So this is equal to r raised to 6 1 upon r square plus 1 upon r raised to 4 dr upon d theta the whole square raised to 3 upon 2 the whole divided by r square plus 2 dr upon d theta the whole square minus r into d square r upon d theta square. Okay, so now we'll just simplify this, students. You will get back rho is equal to r square plus dr upon d theta the whole square raised to 3 upon 2 divided by r square plus 2 dr upon d theta the whole square minus r d square r upon d theta square. Is it clear, students? No? Just here we are going to simplify and we complete the derivation here. So where just put r1 is equal to dr upon d theta, r2 is equal to d square r upon d theta square. Therefore rho is equal to r square plus r1 square raised to 3 upon 2 divided by r square plus 2 r1 square minus r2. This is the equation, students, we wanted to derive, and we have derived equation in polar form. So this is radius of curvature in polar form. Okay, non-stop we are going to go to the next derivation. Please be ready. The next derivation we are going to go is radius of curvature in pedal form. Yes friends, this is also very important, and in the radius of curvature this is the last derivation. Okay, hardly it will take 5 minutes. Let polar form of the equation of a curve be r is equal to f of theta, and I'm going to place the point p r comma theta be a given point on it. Let the tangent to the curve at p subtend an angle psi with initial side. If the angle between the radius vector OP and the tangent P is phi, then we have psi is equal to theta plus phi. This is what we come to know. So this is from figure. If you want, you can go back and see how the figure is given. So we can just see in this figure. I'm going to construct the figure here, radius of curvature in pedal form. So just let P denotes the length of the perpendicular form from the pole O onto the tangent to the curve P, then it forms below. So just a minute. So this is what we get the figure. So I'll just construct this now. I say that this is r is equal to f of theta, and here is our point. P is equal to, just now I mentioned, r comma theta. This is our phi, and this is going to become psi. This is our theta. This is from the origin O. This is our x-axis. This is where the P is there, and next I denote this by yam. Okay, so this is a very simple diagram. Break. Continue. Okay, so I will take, just simplify tan psi. This is going to become sine psi divided by cos psi. So this is equal to r into d theta upon ds. So I just divide and multiply by ds on both the sides. So hence it means that upper, that is in the denominator, numerator sine theta is equal to r into d theta upon ds, and in the numerator we just take this as cos theta is equal to dr upon ds. That's it. So now from previous equation we have seen that 1 upon rho is equal to sine psi divided by r plus cos psi into d psi divided by dr. So where I have put it, this formula? d theta divided ds. Yes. So these two equations, sine and cos, please put it in this equation and denote this equation by, just substitute this equation. So ds, d theta upon ds, substitute all the values, you will get the answer as 1 upon rho is equal to sine psi divided by r plus cos psi into d psi upon dr. Okay, so now just simplification, this is equal to 1 upon r sine psi plus r cos psi into d psi upon dr. So this is what we get the equation. Okay, so just substitute the values, friends. Since we know that r sin psi is equal to p. If this is p, then we will take this equation as rho is equal to r into dr upon dp. If you put the equation r sin psi is equal to p, so we get this. Therefore, this is the pedal form of the radius of curvature. We have another video with more derivation. Please stay with us, and thank you for watching. If you have any doubts, rewind the video once again. You will get all the answers, and all these derivations you can download from the description box. Yes, thank you so much. Thank you.